lesson 11.6, we're going to look at, the binomial theorem, but we're going to use to expand binomials that are to a power, but we're going to actually use Pascal's triangle to do it. So let's take a look at what Pascal's triangle is here. Pascal's triangle is a triangle of numbers that at the very top has a 1. Okay? We actually call this row 0, that top 1 in the triangle. Then right below it, in what we call row 1, is a 1 on the left and then a 1 on the right. So two numbers in row 1. Okay? Each row starts with a 1 and ends with a 1. So this is going to start with a 1, this is going to end with a 1. So in row 2, now to find one more number, there will be 3 numbers in this row. You actually take a look at these 2 numbers, which are right above it. 1 and a 1, you add them together, so it's a 2 in that spot. If I go to my next row, starts with a 1, ends with a 1. Now I add these 2 numbers, that would be a 3. I add these 2 numbers, that would be a 3. So in row 3, it's 1, then 3, 3, 1. Okay, next row, 1, and then this would be 4. If I had the numbers right above it, this would be a 6, this would be a 4, and this would be a 1. That'd be row 4. We're going to continue on. I'll do a couple more rows here. This would be a 1, then a 5, because I add 1 and 4. Add 4 and 6 is 10. There's another 10, 5, and a 1. Then we'll do one more row. 1, 6, 15, if I add the 2 numbers above it. 20, 15, 6, and 1. And obviously, this continues, and it's an infinite triangle. Obviously, the numbers would start to get quite a bit bigger as you move down the rows. Now, we'll look at how this is used to expand binomials to powers. Okay? So we're going to use Pascal's triangle to expand this binomial right here. P plus Q in parentheses to the 5th power. The exponent tells which row to go to from Pascal's triangle. So, if you look here, this has an exponent of 5. It means I go to row 5 in Pascal's triangle. Okay? So, what you want to do is you want to start out writing those numbers. I'm going to move down just a little bit here. But I have a 1, leave a little space, then a 5, then a 10, then another 10, then a 5, and then a 1. Now, look at the sign that's in the middle. In this case, the sign is positive. That tells me all terms, when we expand this, are positive. Okay? So I'm going to go ahead and put plus signs in front of these numbers. So as you can see, there's 1, 2, 3, 4, 5. There's 6 numbers here in row 5 of Pascal's triangle. That means my expanded answer is going to have 6 terms. Now, before I get into actually how you determine these, if you were going to do P plus Q and square it, you would do P plus Q times P plus Q, which would be P squared. Outside terms, you'd FOIL here, plus, let's call it PQ. Let me write that a little neater for you. And then plus another PQ, and then plus Q squared. Well, that'd be P squared plus 2PQ, because each of these would be 1PQ, plus Q squared. So there would be squared. Now you'd take that result, let's multiply it by another P plus Q. So we've looked at how to multiply a binomial times a trinomial, and then that would be what cubed is. Then you'd have to do it another time, take that result, multiply it by another P plus Q, which is a very long process. This process of the binomial theorem, which we're using Pascal's triangle, is a shortcut method to finding the final answer, no matter what the power is. Okay, so what you want to do then is by this first 1 right here, okay, the first term, is you look at the first term in your binomial. It's P. So I start out here, I put a P there, and you always start with whatever the power was on the binomial. So this would be P to the 5th power. On the next term, behind the plus 5, I'm going to take that first term P, and I'm going to raise it to the 4th power. And then you're going to decrease the exponent by 1 each time. So p to the first, and then p to the 0, but remember that's just 1, anything to the 0 power. Okay, then you go to the next term, which is q inside there. So now I start over here with q, and now I'm going to start at 0 exponent, and I'm going to increase the exponents by 1. Oops. That's a q to the 4th, and then the last term will be q to the 5th. So if I take this, now this is 1. So really I have 1 times p to the 5th times 1. So my first term is p to the 5th. And then I have plus 5 p to the 4th, q to the 1st, or just q, plus 10 p cubed, q squared, plus 10 p squared, q to the 3rd, plus 5p q to the 4th, plus q to the 5th, or 1q to the 5th. There is your expanded answer of taking the binomial p plus q and raising it to the 5th power. So if it's to the 5th power, it'll have 6 terms, because that's how many rows, or how many numbers are in that row of Pascal's triangle. Okay, let's go to the next one. Same type of process. Now we have t minus s, the binomial, raised to the 8th power. Okay, so we go to row 8, which is this row right here of Pascal's triangle. So what I suggest doing is going 1, 8, leave some space because we're going to have to fill terms in, 28, 56, 70, 56, 28, 8, and 1. All right, the last one was a plus sign in the middle of the binomial. Notice this is a negative sign. This negative will cause the signs to alternate, and you always start with a positive first term. Because my first term in there is a positive. It's not a negative. T is positive. So what that means is the 1 is going to be positive, then this is going to be negative, then this is going to be positive, this term is going to be negative, this is going to be positive, this is going to be negative, positive, negative, positive. All right, so now go to the first term. First term is t. So I'm going to start over here with t, and the exponent that goes on it is, we went to row 8, or the exponent on it was 8, so t to the 8th, t to the 7th, t to the 6th, t to the 5th, t to the 4th, t to the 3rd, t squared, t to the 1st. Now, t to the 0 is just 1, so basically that's going to cancel out when it's multiplied by the rest of whatever that term is. Okay, then we go to the second term. Now, we've already taken care of the sign, so we want to think of the second term as s. So I'm going to start over here with s to the 0 power. Well, that's just 1. Then I'm going to go s to the 1st. Now I'm going to increase. So s squared, s to the 3rd, s to the 4th, s to the 5th, s to the 6th, s to the 7th, s to the 8th. So let's simplify now. This first term, I have 1 times t to the 8th times, remember this was 1, so it's just t to the 8th, minus 8 t to the 7th s, plus 28 t to the 6th s squared, minus 56 t to the 5th s to the 3rd, plus 70 t to the 4th s to the 4th, minus 56 t to the 3rd s to the 5th, plus 28 t squared s to the 6th, minus 8t s to the 7th, and plus 1s to the 8th, or just s to the 8th. Okay, we were in row 8, so there's actually a 9-term answer for taking that binomial and raising it to that power. And the signs alternate because of the negative sign in the middle. Let's just review what factorials are. 6 factorial. You could use the factorial button on your calculator, but I think there's an easier way to do this. 6 factorial. Remember, factorial means you multiply all the numbers down from 6 to that down to 1. So this really, 6 factorial really means 6 times 5 times 4 times 3 times 2 times 1. So I'm going to write it out that way. Then I have 2 factorial, which is 2 times 1, multiplied by 4 factorial, which is 4 times 3 times 2 times 1. We can do a bunch of canceling. 4 times 3 times 2 times 1 cancels. 2 goes into 6 3 times. So basically everything's gone on the bottom, or I have a 1. I'm left with 3 times 5, which is 15. Now, if you actually found out what 6 factorial is, be a pretty big number, took 2 factorial times 4 factorial, and then divided them, you get 15. But if you notice, if you actually write them out, tons of stuff's going to cancel out. So that's probably the easiest way to do it. I didn't even need a calculator for that problem. All right, now we'll look at a little tougher expansion. When we have a term that has both a number and a variable on it. Notice the first term in this binomial is 3x. Okay, so nothing changes with as far as the exponent here tells me to go to row 4, which is 1, 4, 6, 4, 1. So I'm going to go 1, 4, 6, 4, and 1. Now, notice there's a negative sign in the middle. Causes the signs to alternate, starting with a positive. So the 1 is positive, this would be a negative, this is going to be a positive, this is going to be a negative, this is going to be a positive. If that would have been a plus sign, they would all have been positive. All right. Now here's how this changes. The first term is 3x. So what you want to do is I want to take 3x. When there's a number and a variable, I suggest you put it in parentheses. And I want to start with whatever the exponent was here, which is 4. Now I want to do 3x to the third. Then I want to do 3x squared. Then I want to do times 3x to the first. And then times 3x to the 0. So you have to use parentheses when there's a number and a variable. Okay, now we're going to do the second term. Now the second term is just y. We've already taken care of the signs with the negative causing the signs to alternate. So now I'm going to go y to the 0, which is just going to be 1. Then I'm going to go y to the first, y to the second, y to the third, and y to the fourth. So let's simplify here. Now notice this right here, 3x to the fourth. I'll just do it up above here. That means I take 3 to the fourth and x to the fourth. 3 to the fourth is actually 81. Okay, and then x to the fourth. So I do 3 to the fourth, which is 8. So this is going to be 81 x to the fourth, and then it's times 1 times 1. So my first term will be 81 x to the fourth. So notice when a term has a number and a variable, you don't end up with your final answer having the numbers from that row of Pascal's triangle. Initially they'll be that, but because you have to take that number that's in one of those terms to a power, that's going to cause the coefficients to be different than they are just the numbers from that row in Pascal's triangle. Here, I'm going to do 3x in parentheses to the third. I take 3 to the third, which is 27, and I take x to the third, which is 27x to the third. Now I want you to notice what you have here. I have to take this 4 times this 27. There's a minus sign. So 4 times 27, if you actually do that, is 108. Again, that comes from multiplying those two numbers. And then I have x to the third and y to the first. Okay, next term. I'm going to go ahead and square this. That's 3 squared, or 9, and then x squared. 6 times 9 is 54. And then I'm going to have my x squared from right here. Again, the 54 came from multiplying those two, and y squared. Here, 3x to the first is just 3x. I take 3 to the first, x to the first. But now I have to take the 3 times the 4, which is going to be 12. And then I have x to the first, y to the third. 3x to the 0 is just 1. So I have 1 times y to the fourth, which is y to the fourth. There's my final answer for the expansion of that binomial using Pascal's triangle. Now, when you go to finding a particular term, you don't have to do all the terms in your answer or end up with multiple terms. You kind of have to think of, we want the fourth term of this right here. So this exponent still tells me go to row 4, which I did on the last problem, but there's row 4. So what I would start out doing is just like we were going to do the whole expansion, 1, 4, 6, 4, and 1. There's a plus sign in the middle, which tells me all signs are positive. Okay, fourth term. So if I count over, this would be first, second, third, fourth. So I'm looking right here where I have this plus 4. Okay? Now, the binomial we're expanding is a plus 3b to the fourth. So this would be, this term right here would be a to the fourth, then a to the third by the second term, then a to the second, a to the first. So I don't have to fill all that other stuff in, but this is going to be a to the first. Okay? And then I'm going to have my second term of 3b, but what's the exponent going to be on it? Okay? Well, this would be, again, this was an a to the fourth, and then it would have been 3b to the 0. Next term, or the second term, would be 3b in parentheses to the first. With the 6 right here, it'd be 3b to the second. This would be 3b in parentheses to the third power. So I'm kind of focusing just on this term. So I kind of have to think about the other terms, but they're only asking me for that specific term. Okay, if you want to do the whole expansion, you can, and then just pick out that term at the end. Okay, but you just kind of have to think about the exponents. And one little hint with the exponents that I would suggest is these two, if you notice, the exponents have to add up to what your exponent was on your binomial that you are expanding. So this term, now 3b to the third, would actually be 27b to the third, and then I have to do it times 4a. So 4 times 27 would be 108, and then we'd have an a to the first and a b to the third, and it would be a positive term. So there is the fourth term in that expansion. And again, if you want to do the whole expansion and then just list the fourth term, that certainly is okay. All right, and that is the lesson.